Welcome to Lesson 1 and the Nature of Science. Our objectives for this lesson: differentiate between a law and a theory, and a hypothesis and a theory, and explain how models are used in authentic scientific inquiry. Much of what you learn throughout your years in school in science class has focused mainly on the products or the outputs of science, what we know. And there's been very little focus on the other major important part of science, which is the process of science. How do we construct new knowledge? So in this course, we're going to look at both equally. So let's first then define what is a hypothesis. Well, it's not an educated guess, as we've learned. A hypothesis is a testable statement about the natural world around us. So for example, if you question, are all swans white? And you always see white swans, then you can say, I have a hypothesis that all swans are white. And so this is a testable statement. We can go out and collect data about this phenomena. And so you go out and you do that to test your hypothesis. And you find that all swans are white until one day you come across a black swan. And so, as a scientist, you do not simply reject that hypothesis if it's falsified. You just go back and you modify it. So we can modify our original hypothesis that all swans are white and say that all swans are white only in the summer. And then I can go and collect data on that. And if my hypothesis is still falsified, I go back and modify it again. And scientists keep doing this over and over, and this is how they build a very strong hypothesis for a phenomena. When we talk about a scientific theory versus a law, there's also the misunderstanding that a theory turns into a law over time, and that is not true. Laws and theories are very different. A law is a repeated pattern or observable event, such as gravity. It's something that we can observe with our five senses, and we can repeat it over and over and over. So if I drop an apple every day, the apple is going to fall. So I could observe that force of gravity, and that's why gravity is considered a law. It's representing a pattern. A theory is an explanation for those patterns. So an explanation as to how or why something is happening. So it's explaining the observable law. So theories, therefore, are unobservable. We can't see them. We can only base them upon inferences and deduction. An example of a scientific theory would be the theory of evolution. We observe that species change over time, and therefore an explanation for that pattern as to why it's occurring or how it's occurring is the theory of evolution. So let's check your understanding. Can you differentiate between a law and a theory? When we compare a hypothesis to a theory, a hypothesis is an explanation for a very narrow set of phenomena, like the example where all swans are white. A theory is a more broad explanation of a wide range of phenomena. Theories often integrate many hypotheses. And so again, the example of the theory of evolution. This consists of many hypotheses as to why species are changing over time. So let's check your understanding. Can you differentiate between a hypothesis and a theory? It is also important then to differentiate between an observation versus an inference. An observation is information that we get through using our five senses. An inference is something that we can't observe or see. It's an explanation or interpretation of what you're observing using or based upon your prior knowledge or experience. So for example, I have a plant here and the plant is wilted. So my observation is that the plant is wilted. My inference is that the plant needs water. Because based on my prior experience, I know that when plants need water, they end up wilting and looking like this. So again, the observation is something we see, the plant is wilted, and the inference is the explanation or interpretation of that, based on my past experience. So as we focus on the process of science, the formation of understanding and new knowledge, we're going to use models in class almost daily. So what are models? Well, models are things we've seen throughout our career in science. They are a simplified version of reality. And there are many types of models. And we use them to understand or try to explain something. And models suggest how things work or may work. So scientists and students will use models all the time as they are trying to understand things. So there are three main types of models that are used in science. We have the conceptual model, like the carbon cycle used in neuroscience. We have mathematical models, like E equals mc squared. And we actually have physical models, such as a globe. All these models are useful. They are equally important. They're used in many different ways, and oftentimes when we're trying to understand something, we'll use more than one type of model. So we can actually use all three types of models. So a good model then should explain our data that we have. It should accurately predict the results of any future experiments, so we can actually use the model to try to understand something now as well as in the future. And good models are consistent with our prior knowledge, what we already know, and they build upon what is known and be logically consistent. But there are problems with models. The major problem is the confusion of the model and reality. This is very common among students as well as the general population. And we confuse these models with being reality, and that's not the case. A model is just a way to help us understand something that is very complex. So therefore, models then could end up limiting our mental conceptualizations of the natural world. For example, we use models all the time in medicine, for example. And if we're testing out a new drug, we're not testing those on humans, we're testing them on models. And the models can be very simple, single-celled organisms. And so when a drug works for that model, we can't assume it's going to work for humans because, again, the model is a very simplified version of reality, and humans are very complex. So the point of using the model is just to help us understand this complex mechanism and then eventually try to, in this case, come up with a better drug. Let's check your understanding. Can you explain how models are used in authentic scientific inquiry? At this point, you should be able to differentiate between a law and a theory, as well as a hypothesis and a theory, and explain how models are used in authentic scientific inquiry.